Our world is home to incredible structures brought to life through extraordinary imagination. In these places, the line between an incredible miracle and a devastating disaster is only a matter of inches. Many of these structures were once considered impossible to build, even by the engineers themselves. But through ambition, bold determination, and remarkable ingenuity, humanity turned the impossible into reality. And today, together with our nearest we're going to explore some of the most dangerous structures on Earth. These are places that seem to defy both nature and gravity itself, seriously. There are structures so... This is China's massive concrete and steel giant, the Three Gorges Dam. It's not only the largest hydroelectric power project on Earth, but also one of the most controversial and awe-inspiring engineering feats ever built. Stretching over 3 kilometers long and standing about as tall as a 60-story building, this dam holds back an astonishing 3 billion cubic meters of water in the Yangtze River. Building it required 28 million cubic meters of concrete and 463,000 tons of steel, enough material to build 63 Eiffel Towers. But the incredible weight of all that stored water has created enormous geological pressure. NASA scientists have even confirmed that the massive amount of water concentrated here changed Earth's moment of inertia, slightly slowing the planet's rotation and making each day a little longer. If the dam were ever to collapse, a tsunami hundreds of meters high could surge downstream, sweeping through dozens of cities and putting more than 400 million lives at risk. It's hard to imagine where China found the confidence to complete a project like this, or how it could possibly respond if the worst-case scenario ever became reality. Take a look at the Morning Glory Spillway, a giant black hole-like structure sitting right in the middle of a lake. This isn't a natural phenomenon, but a massive Morning Glory-shaped drainage system with a diameter of 22 meters. Once the lake level rises above its limit, it activates, turning the calm surface into a violent, seemingly bottomless sinkhole. Its power is incredible, capable of swallowing more than 137 cubic meters of water every second. The water plunges straight down a vertical shaft, about 75 meters deep, creating such intense pressure and speed that no living creature or boat caught in the whirlpool could survive. What continues to impress engineers is its ability to withstand enormous water pressure while controlling the flow to keep the dam's foundation from eroding. The ingenuity of the Americans, who came up with this groundbreaking idea and successfully brought it to life, is truly remarkable. Located on the border of Arizona and Nevada, Hoover Dam is an incredible achievement built through the blood, sweat, and determination of tens of thousands of workers during the Great Depression. Built in the 1930s, this massive dam rises more than 220 meters tall and required about 3.3 million cubic meters of concrete. At the time, engineers faced engineering challenges unlike anything seen before. If they had poured that enormous amount of concrete all at once, the heat produced as it hardened would have cracked the structure immediately, and even then it would have taken 125 years to cool completely. To solve the problem, they installed a massive cooling system with more than 930 kilometers of pipes running through the concrete. For the early 1900s, it was nothing short of a miracle. The danger came not only from the work itself, but also from the brutal desert heat, where more than 100 workers lost their lives during construction. In your opinion, which is more impressive, Hoover Dam or China's Three Gorges Dam? Let us know your thoughts in the comments below. Since opening in 2017, the Louvre Abu Dhabi has amazed the world with a design that seemed almost impossible to pull off. The entire complex is made up of 5 building sections constructed directly above sea level. Its most striking feature is a massive dome that spans 180 meters, weighs about 7,500 tons, yet appears to float effortlessly in mid-air. In reality, the dome is supported by 4 hidden columns. The dome is made from 850 metal stars woven together across 8 intricate layers. As sunlight filters through the openings, it creates a breathtaking pattern of light across the entire space below. To build it, engineers first drained the seawater using a temporary dam system, then allowed the water back in only after construction was complete, so it could surround the museum. A single mistake in the corrosion protection system against salt water, or even a small miscalculation in water pressure, could have left this awe-inspiring, multi-billion-dollar masterpiece permanently underwater. Palm Jumeirah stands as a bold and unapologetic declaration of humanity's ambition against the sea, known as the world's largest man-made island. This incredible structure is shaped like a giant palm tree. From the sky, it looks like something straight out of a futuristic sci-fi movie. The most amazing part is that not a single bit of concrete or steel was used to build the island's foundation. Instead, the builders used 94 million cubic meters of sand and 7 million tons of rock. The entire structure is held together solely by the friction of the seabed sand and the weight of the rocks. To create its perfect palm shape, engineers relied on GPS satellite navigation from space to precisely guide every sand placement. The total value of this massive project is estimated at around $10 to $20 billion. But the real threats have never gone away. Geologists warn that the island faces constant erosion from natural ground settlement and the powerful waves of the Persian Gulf. The Leaning Tower of Pisa is a complex engineering puzzle that has challenged experts for centuries. It's the clearest example of how a single mistake can create a structure that's both dangerously unstable and endlessly fascinating. The tower weighs an estimated 14,500 tons, yet it was built on a foundation only 3 meters deep over soft clay soil. Because of that critical flaw, the tower had already started leaning by the time the 3rd floor was completed. After more than 800 years, its tilt had reached a dangerous 5.5 degrees by the end of the 20th century. As the tower's center of gravity shifted, enormous pressure built up, putting the marble on the leaning side at constant risk of cracking apart. To save it, engineers carried out an unprecedented rescue operation by removing dozens of tons of soil from the opposite side and using massive lead counterweights to pull the tower back. Today, its lean has been stabilized at about 3.97 degrees. But to engineers, the Tower of Pisa is still like a patient that requires careful monitoring every single day. Standing in the heart of vibrant Barcelona, the Sagrada Familia is a living masterpiece that has been under continuous construction for more than 140 years, defying every standard of time and architectural complexity. What amazes modern engineers is the visionary genius of architect Antoni Gaudí, who designed geometric structures so complex that the mathematics of his time couldn't fully explain them. Its most remarkable features are its forest of cactus-like columns and its intricately interwoven, vaulted roof system. To complete the tallest tower, the 172.5-meter Tower of Jesus Christ, engineers had to fabricate prefabricated stone blocks weighing dozens of tons and lift them to breathtaking heights with ultra-heavy cranes. Even more remarkable is that the project combines traditional 19th century stone craftsmanship with modern 3D printing and computer-aided design technology. Even today, the cathedral is still under construction, while continuing to welcome visitors from around the world. This is the Millau Viaduct, with its tallest pylon reaching 343 meters. This bridge stands taller than the Eiffel Tower, and is the tallest bridge in the world by structural height. Engineers had to build 7 massive concrete piers on extremely steep and unstable terrain to connect the bridge deck, which weighed tens of thousands of tons. At such a dizzying height, they abandoned traditional methods and instead used a launching technique that pushed the steel deck outward from the ends of the cliffs. The margin for error was only a few millimeters, and under wind gusts reaching 200 kilometers per hour, even the slightest misalignment could have twisted or collapsed the entire structure. What impresses experts most is this 2.5-kilometer bridge's ability to accommodate thermal expansion. Under the mountain region's blazing sun, or bitter cold, the bridge can expand or contract in length by as much as several meters, challenging everything we thought we knew about urban transportation. Let me introduce China's Wuhan Skyrail, a structure that looks like it came straight out of a sci-fi movie. It's China's first commercial suspended monorail system, featuring trains that travel while hanging upside down beneath the track. What amazed engineers around the world is this gravity-defying design. The entire passenger car is made with transparent glass, offering a 270-degree view, and even the floor is reinforced glass, making passengers feel as if they're flying through the sky. To keep dozens of tons of steel suspended in mid-air while traveling steadily at 60 kilometers per hour, the suspension system and magnetic forces have to operate with absolute precision. In particular, China had to develop an intelligent damping system and multiple layers of safety locks to ensure the train never leaves its one and only suspended track. It's proof that humanity is willing to leave the ground behind in order to conquer urban space in one of the boldest and most dangerous ways imaginable. Take a look at the Veluwemeer Aqueduct in the Netherlands, an engineering masterpiece that seems to fool every one of your senses. It's a one-of-a-kind engineering achievement, made possible by completely rethinking the traditional approach to bridge design. Instead of building a bridge for cars to drive over the water, they built one that lets the water flow over the road. Designed to be 25 meters long and 19 meters wide, the aqueduct allows deep draft boats to pass overhead freely without disrupting the traffic below, on average around 28,000 vehicles travel through the tunnel beneath the 3-meter-deep waterway every day. The biggest challenge comes from the enormous weight of the water and the boats overhead pressing down on the vehicles traveling underneath. To maintain this delicate balance, engineers drove thousands of tons of steel sheet piles deep into the ground to stop leaks and keep the roadway completely dry, seen from above. The Veluwemeer Aqueduct looks as if the sea has been surrealistically sliced apart, making room for people to pass through beneath it. When it comes to structures that push every limit of modern engineering, nothing stands out more than Dubai's Burj Khalifa, standing an incredible 828 meters tall. This tower is currently the tallest structure in the world. So how does such a slender building withstand powerful winds without toppling over? To solve that problem, the architects designed the tower with a Y-shaped layout that breaks up and redirects the wind using a divide-and-conquer approach. This design prevents the resonance that could otherwise threaten the building's stability. The tower's foundation system is another remarkable engineering achievement. Its 192 concrete piles extend more than 50 meters underground, allowing nearly 500,000 tons of steel and concrete to stand firmly on sandy ground. The most mind-blowing part is how it was actually built at such dizzying heights. To pump concrete all the way to the highest floors, engineers used ultra-high pressure pumps, unlike anything ever seen before. The Burj Khalifa is more than just a symbol of wealth. It's also a testament to humanity's bold ambition. Standing 632 meters tall, Shanghai Tower is the tallest building in China. What stunned engineers around the world is its unique 120-degree twisting design, a bold yet incredibly clever architectural solution, created to withstand the powerful typhoons that frequently strike the city. This design not only reduces wind loads on the structure by up to 24%, but also saved more than $58 million in construction materials. But the real challenge was supporting an 850,000-ton structure on the soft soil and river sediment at the mouth of the Yangtze River. To keep the tower from sinking or tilting, engineers drove 980 concrete piles more than 86 meters into the ground and poured its massive foundation continuously for 63 straight hours. Near the top of the tower is a giant tuned mass damper, weighing 1,000 tons. It is the largest damper of its kind in the world, using advanced technology to control the building's movement and reduce the effects of typhoons and earthquakes. Shanghai Tower stands as a symbol of the perfect fusion of art and engineering, showing how humanity used the elegance of curves to overcome the raw power of nature. This ambitious project consists of 300 artificial islands, arranged in the shape of a world map, built using 321 million cubic meters of sand and 31 million tons of rock. The biggest risk is that the islands sit completely isolated in the open ocean, about 4 kilometers off the coast, making it incredibly difficult to protect them from erosion. In 2010, shocking reports claimed the islands were slowly sinking beneath the sea, and that the sandy channels between them were filling in because of tidal changes. To keep the project alive, engineers have had to carefully plan massive breakwater systems and implement advanced water management technology. Construction began in 2003. But to this day, most of the islands remain nothing more than barren piles of sand. Even after an enormous investment of $1.4 billion, there's still a very real chance this project could become a ghost development, swallowed by the ocean. Located in the foggy city of Chongqing, the Chongqing rail transit system is one of the strangest transportation networks in the world. Because of its steep mountainous terrain and dense population, engineers had to abandon traditional construction methods and create rail lines that pass through high-rise buildings and race along towering cliffs. The most unforgettable sight is Liziba Station, where Line 2 runs directly through a 19-story apartment building between the 6th and 8th floors. Even more amazing is that when the train, weighing dozens of tons, passes through, the people living inside don't even feel the slightest vibration. On top of that, the city's complex multi-level design means a location can be on the 10th floor from one street, yet at ground level from another, while safely serving millions of passengers every single day. Isn't that incredible? Chongqing Rail Transit proves that with enough creativity, there's no landscape humanity can't overcome. Suspended high above a deep canyon in China, the Sidu River Bridge is a remarkable achievement that conquered terrain once thought impossible, rising 496 meters above the canyon floor. This bridge held the title of the world's highest bridge for many years. The engineers' biggest challenge was figuring out how to get the first guide cable across a span of more than 900 meters in such harsh mountain terrain. After trying a solution that was both creative and incredibly risky, they turned to a military rocket. It was the first time a rocket had ever been used in bridge construction. And while the idea sounded crazy, it delivered pinpoint accuracy. The Sidu River Bridge was challenging, not only because of its record-breaking height, but also because of the extreme conditions involved in building it. But the payoff was enormous, cutting travel through the rugged mountains from several hours down to just a few minutes. Suspended precariously between two steep cliffs in Zhangjiajie National Forest Park, the Grand Canyon Glass Bridge was an extreme challenge for even the most experienced structural engineers. Stretching 430 meters long and hanging 300 meters above the canyon floor, this bridge is one of the world's longest and highest glass pedestrian bridges, where the line between pure excitement and sheer terror is nothing more than a single layer of transparent glass. To safely support thousands of visitors at the same time, the designers used 99 ultra-thick tempered glass panels, each made by bonding 3 layers of glass together. To prove its durability, they carried out extreme tests, including smashing the glass with a massive sledgehammer and driving a 2-ton truck across it. In a narrow canyon like this, powerful whirlwinds can generate enough force to twist the entire bridge. To solve that problem, the engineers installed more than 70 giant glass ball dampers, each weighing hundreds of kilograms, to counteract the bridge's vibrations. The Øresund Bridge connecting Denmark and Sweden is one of the most extraordinary transportation systems in the world. The 8-kilometer cable-stayed bridge suddenly disappears, diving beneath the sea and transforming into a 4-kilometer underwater tunnel. The danger and complexity of this $4 billion project came from its extremely sensitive geographic location. Engineers couldn't build the entire crossing as a bridge, because it would have interfered with flight paths into nearby Copenhagen Airport and blocked the passage of large ships. Their solution was to create a 4-kilometer-long artificial island called Pebberholm, using 9 million cubic meters of sand and rock dredged from the seabed. Using the island as the transition point, they lowered 20 massive concrete tunnel sections to depths of several dozen meters below the surface. The Øresund crossing stands as a powerful symbol of limitless human creativity, completely reshaping the map of Northern Europe. Next is the Line in Saudi Arabia, a project that's challenging everything the modern construction industry thought it knew. Part of the massive NEOM project, this vertical city stretches 170 kilometers long, is only 200 meters wide, and rises 500 meters high as a giant mirrored structure. The engineer's ambition is to fit the entire lives of 9 million people into this single structure standing in the middle of the harsh desert. The line faces enormous challenges, from its unprecedented scale to thermal expansion under the Gulf's intense sun and the region's extreme geological conditions. Unveiled in 2021 with a target completion date of 2030. The project has faced constant criticism over its staggering cost, unrealistic timeline, and seemingly impossible design. What do you think? Will this extraordinary structure ever be completed? Or will it remain an unfinished dream forever? The Statue of Unity is not only the tallest statue in the world, but also an extraordinary feat of structural engineering that pushes the limits of gravity. Standing at a record-breaking 182 meters, the statue is twice as tall as the Statue of Liberty. At that height, the structure has to withstand wind gusts, reaching speeds of up to 180 kilometers per hour. To make that possible, engineers used 210,000 cubic meters of concrete and 18,500 tons of structural steel, while the exterior was assembled from 500 extra thick bronze panels to keep the structure from twisting during powerful winds or earthquakes. Up to magnitude 6.5, 2 massive 500-ton tuned mass dampers were installed inside to absorb the vibrations. The total cost of building this monument came to $400 million. The statue honors Sardar Vallabhbhai Patel, the leader who played the biggest role in uniting more than 500 princely states to help build a unified India. Deep beneath the salty waters of the English Channel, the Channel Tunnel stands as one of the greatest and most dangerous engineering achievements of the 20th century. Of its total length of about 50 kilometers, an incredible 38 kilometers run entirely beneath the seabed, making it the longest undersea tunnel in the world. The total cost of this project reached $15 billion. Looking back on the construction, engineers say the most terrifying part was having to precisely control giant tunnel boring machines, weighing thousands of tons 45 meters beneath the seabed, where water pressure was immense. The two excavation teams, starting from opposite ends in France and the United Kingdom, had to meet precisely beneath the middle of the sea, with a margin of error of only a few centimeters. To make that possible, the most advanced surveying and satellite navigation systems available at the time were used. Engineers also built a third service tunnel between the two main tunnels to serve as the only evacuation route in the event of a fire or any technical emergency.